welcome back. I'm so glad you're here. I wanted to follow up with you on a conversation that we had last time about bacterial cells and viruses. Remember, there's a lot of differences between them, and I realized when we were done talking that I have more that I want to tell you. So I'm so glad that we can finish up that conversation today. So remember, we talked about bacterial cells and viruses and how they both cause diseases in humans, but how we treat them in very different ways. So remember, viruses, best rule of thumb for getting rid of them is generally just rest and hydration. With bacterial infections, you need to get antibiotics to treat them. And antibiotics, what they actually do is they target the bacterial cells in two ways. One is they bust open that cell wall on the outside, so by busting it open, it kills the bacterial cell. The other way that antibiotics can work is by shutting down the protein factories inside of the bacterial cells. So when you do that, that kills the bacterial cell as well. So what I wanted to talk to you about is this idea that antibiotics are being overused dramatically these days. And when you overuse antibiotics, that can lead to antibiotic resistance. And that's a real problem, and it's something that we need to be concerned about. And I wanted to explain the situation to you. First of all, let's think about this. It's actually a very beautiful situation when we talk about what is bacterial resistance, because it's actually just evolution. And evolution is simply when you have small changes in the DNA. Those changes in the DNA lead to either good, bad, or silent mutations. So a bad mutation would be something bad, right? Something that causes a disease or something in the body. Silent meaning no effects at all. But then there can be good mutations too. And good mutations can lead to adaptations that work. So we look the way we look and not like a little bacterial cell because of all the good adaptations that we've had over time, over the evolutionary time since we were very tiny. So I wanted to show you just a general idea about what evolution actually is. So think about animals that live in the Arctic. What color are they? White, right? They're going to be white. Say this is a rabbit that's living in the Arctic and it's white, and so we have our Arctic snow and ice here. This rabbit is camouflaged, right? So this rabbit can live long enough to reproduce. It's not going to get eaten by predators. But think about this. If we took this rabbit and it had babies, and say there was a random mutation in the DNA for the fur color, and this mutation led to a rabbit that was black fur color, right? Now look at this. You can see that our white rabbit is camouflaged, looking good, but this black fur rabbit is not going to do very well, right? It's going to be eaten very quickly, so it's not going to live very long, and it's not going to be able to reproduce and pass those new genes on. So what is happening is that the environment, Mother Nature, is selecting for the traits that actually work. That's evolution. So it's not that traits are good or bad, it's just what happens in the particular environment. So say the situation changes. Say that we have black lava rock underneath this ice, and what happens is that our ice and snow melts, and we're left with black lava rock. Here's our black fur rabbit, and here's our white fur rabbit. Now which one is working better? Right? In this case, with the black lava rock, our black rabbit is doing really well. It's going to be able to hide, get away from those predators, and live long enough to reproduce and make more babies with black fur. But in this case, this white fur allele, that's not good at all, because this guy is going to be eaten before it can have babies. So that's the whole idea of evolution, that you have these small changes over time, and the environment or Mother Nature selects for what actually works. So when we look at how that actually relates to our bacterial cells and overuse of antibiotics, and again, when I talk about overuse of antibiotics, I'm talking about the idea that people will go to the doctor with viral infections and beg the doctor for medicine, and the doctor will write prescriptions for antibiotics, when really that's not necessary at all. Also, farmers are using a lot of antibiotics in their animals to help them grow very quickly, and because they're overcrowded in unsanitary conditions. So that's the overuse idea. So we need to be good stewards of antibiotics, and that's a term that people are using now to describe the situation, where we want to make sure that we're not begging the doctor to give us antibiotics unless it is a real bacterial infection. We want to make sure that we are talking to our legislators and telling them that we think this is an important issue. Hopefully we'll then talk to pharmaceutical companies. Pharmaceutical companies are making drugs for profits, of course, and antibiotics unfortunately don't make a lot of money, so they're not really interested in creating new antibiotics, but we need to encourage them to do that, again, because we want to make sure that we're in a situation where we can treat simple bacterial infections and we're not dying from these simple bacterial infections. So again, remember that bacterial cells are treated by antibiotics and viruses are treated with antivirals, but generally just rest and hydration. Most of the time when you're sick, it's going to be a virus. So wait a couple of days before you go to the doctor, right? Just try and see if things get a little bit better for you. If they don't, do go to the doctor, but make sure that it actually is a bacterial infection that you have before you sign up to take those prescriptions. Again, we want to make sure that we're taking all of those prescriptions as prescribed. Don't throw those pills away as soon as you feel better. Do your part, right? Everybody can do their part to make sure that this situation doesn't get worse.